So this is Dr. Hanaa Assil, and this is paper 2C of June 2023 in the Pearson Edexcel IGCSE Chemistry. So let's take a look at the questions and discuss the answers. The first question says, use the periodic table to help you answer this question. Of course, at the beginning of your exam, there is a copy of the periodic table. And the question wants the name of the element with atomic number 14. Remember, the atomic number is the small number for the element. So if we look at the periodic table, silicon has numbers 14 and 28, and that means it has atomic number 14 and mass number 28. Name the element in group 2 and period 3. Where is group 2, period 3? First of all, the groups are the vertical columns. So magnesium is in group 2 and the periods are the horizontal ones. So hydrogen and helium is period 1. From lithium to neon, that's period 2. From sodium to argon, that's period 3. So the element in group 2 and period 3 is magnesium. Name an element that's a liquid at room temperature. Which element is a liquid at room temperature? Remember, we have only 2 liquids in the periodic table. The only liquid non-metal is bromine, and the liquid metal is mercury. Everything else is either a solid or a gas. Give the electronic configuration of an atom of phosphorus. Again, we look at the periodic table. Where is phosphorus? This is phosphorus. We are required to give the electronic configuration. That means we need to know how many electrons. Of course, the electrons is the same as the atomic number, which is the small number. So the atomic number of phosphorus is 15. So an atom of phosphorus would have 15 protons and 15 electrons. How do we distribute the electrons? Remember, the first energy level takes 2, then the next energy level takes up to 8, and we're still left with 5, so it goes into the third energy level. Give the formula of sodium sulfide. How do I write the formula of sodium sulfide? Well, I need the symbols first. So the symbol of sodium, Na, sulfide is sulfur. We said anything with a D is the element in the periodic table. So sulfide is S, and then we need to put the valency of one under the other. Sodium is in group 1, so valency 1. So the S has 1 under it, which is not written. But the valency of sulfur is what? Sulfur is in group 6. It needs 2 electrons to have a full outer shell. So its valency is 2. The 2 goes under the sodium. So this is the formula of sodium sulfide. Explain in terms of electron configuration why neon is unreactive. Where is neon? Neon is in group 0, and we know that everything in group 0 has a full outer shell of electrons, so it doesn't need to lose or gain electrons. So we say it is unreactive. This question is about gases in the atmosphere. Which of these gases has the lowest percentage by volume in the atmosphere? What is the composition of air? You should know that nitrogen is 78%, oxygen is 21%, argon is 0.9%, but the one with the lowest percentage is carbon dioxide. It's only about 0.03 or 0.04%. When copper carbonate is heated, copper oxide and carbon dioxide form. What is the name of this type of reaction? So if I heat copper carbonate and it breaks up into 2 or more substances, so in this case it breaks up into copper oxide and carbon dioxide, this is called decomposition, and Actually, when it is using heat, it is actually called thermal decomposition. So the type of reaction here is thermal decomposition. What is addition? You should know that this is not addition, because addition is when we form one product. When one product is formed, that's an addition reaction. So nitrogen plus hydrogen to form ammonia, that is addition. What is oxidation? Oxidation is gain of oxygen. So copper plus oxygen to form copper oxide, that is oxidation. What about substitution? Which types of compounds do substitution in our syllabus? You should know that alkanes, when they react with halogens and it needs UV light or ultraviolet radiation, this is substitution because one of the hydrogens is replaced by chlorine. So remember that alkanes, when they react with halogens, that is a substitution reaction. Okay, anyway, which color change occurs when copper carbonate is heated? Again, we're heating copper carbonate. You should know these colors. What is the color of copper carbonate? You should know that it is green. When I heat it, it turns to copper oxide, and you should know that copper oxide is black. So the color change here is green to black. Give the chemical equation. We already wrote this equation somewhere. So copper carbonate, remember valency of copper is 2, valency of carbonate is 2. So you don't write anything under either of them. Copper oxide, again valency of copper is 2, valency of oxygen is 2, plus carbon dioxide, and it is already balanced. Remember, don't leave an equation until you balance it or you check that it is already balanced. A student uses this apparatus to find the percentage of oxygen in a sample of air. The student leaves the apparatus until there is no further change in volume of gas in the syringe. So what is happening is we have in the flask wet iron fillings, and of course there is air or oxygen around it. So of course the iron will rust. Rusting means it is going to take the oxygen from the air, so the gas syringe will go in because the volume of gas will decrease. So, volume of gas in the flask and the connecting tube is 280. The volume of gas in the syringe alone at the start is 100. And at the end, it is 27. So, how do we calculate the percentage of oxygen in the air? Remember, the air fills the flask and the connecting tube and the gas syringe. So, to get percentage oxygen, we need to see the volume decreased by how much. It started in the gas syringe 100 and ended up with 27. So, the difference is the oxygen that was used up. And then we need to divide it by the total volume of air that was in the flask in the beginning. So we are told that the flask and the connecting tube is 280 and the syringe is 100. So actually the total volume of air we started with was 380. Out of that, only 73 was oxygen, because that is the decrease in the volume, times 100, this gives 19.2%. Are we finished? No, we haven't. The question says, give your answer to what? To two significant figures. So if you don't change this to two significant figures, you lose a mark. So two significant figures would be 19%, not 19.2. 19.2 is three significant figures. Explain why an increasing amount of carbon dioxide in the atmosphere is likely to cause a problem for the environment. What is bad about carbon dioxide increasing in the air? Remember that carbon dioxide is a greenhouse gas, and this causes global warming. And of course, And of course, the global warming means rise in temperature of the earth, melting of the ice in the north and south poles, and this leads to flooding. Question 3 says, this question is about alcohols. Ethanol can be manufactured using two different methods, hydration of ethene or fermentation of glucose. This is the equation for hydration. You should know that ethene, C2H4, you add steam, it gives ethanol. The equation for fermentation is what? You should remember that fermentation means I'm going to put yeast on glucose, and this changes it into what? Into ethanol. This is how we write ethanol in an equation, C2H5OH plus carbon dioxide, and please don't forget to balance. So this is the balanced equation for fermentation. Glucose, which is C6H12O6, changes into ethanol, C2H5OH plus carbon dioxide. The table gives some information about the two methods. So we're comparing here hydration of ethene with fermentation of glucose. What is the catalyst in hydration of ethene? Remember, hydration of ethene means I'm going to add steam in presence of what? Concentrated phosphoric acid, 300 degrees Celsius. What is the temperature in fermentation? Remember, fermentation is when I put glucose in water and then using the enzymes in the yeast, and we said yeast has enzymes called zymase, and that acts as a catalyst for fermentation. We do fermentation at what temperature? Around 30, you can say 35, room temperature, around, just slightly over room temperature. Then, for hydration, what was the pressure we're supposed to use for hydration of ethene? So we said hydration of ethene is we add steam in presence of phosphoric acid, 300 degrees Celsius, pressure is 60 to 70 atm. Of course, when we're comparing, you should remember, even if the question does not tell you, hydration is a faster process and provides a pure product, while fermentation is slow and the product is impure. So when he says, explain one advantage and one disadvantage of using fermentation rather than hydration. So we're talking about fermentation. What is the advantage and what is the disadvantage? And he says you should use information from this table. So what is the advantage of using fermentation? Remember that we use fermentation, we use glucose. Where do we get glucose from? We get it from sugar cane, and that's a renewable resource. So that's actually one of the advantages of fermentation. But he says I should use the information from the table. So from the table, the advantage is the temperature is only 30 and the pressure is 1 atmosphere. So I'm doing fermentation at low temperature, atmospheric pressure. That means less energy is needed. But what is the disadvantage of fermentation? Remember, we said the disadvantage is that it is a slow process and it provides impure product that needs to be further purified. Explain why fermentation needs to occur in the absence of air. Remember that this is what we call anaerobic respiration. Fermentation should occur in absence of air. It's an anaerobic process, and if I have oxygen present, the product which we want, which is ethanol, will be further oxidized by the oxygen. So instead of getting ethanol, we get ethanoic acid. So we need to do this in absence of oxygen or in absence of air. Propanol has this percentage composition by mass. Show by calculation that the empirical formula of propanol is this. How do we calculate empirical formula? Please remember, we put the percentages. Then we divide each one by the mass number of each of them. The numbers that come out, we divide by the smallest. The numbers that come out should be whole numbers, so these are the ratios, and that means that the empirical formula is C3H8O. Draw the displayed formula of propanol. How do I draw propanol? You should know that. Prop means how many carbons? Means I should be drawing 3 carbons. And all means I have an alcohol, so I must have an OH somewhere. So this is the displayed formula of propanol. Remember again, each carbon cannot have more than 4 bonds. So if we were drawing something with a double bond or an acid or something, please be careful that only 4 bonds should come out of each carbon atom. Question 4 says, a student does a titration to find the concentration of potassium hydroxide solution. This is the student's method. Add 25 centimeter cubed of potassium hydroxide solution to a conical flask. Add a few drops of methyl orange indicator to the conical flask. Fill a burette with dilute sulfuric acid and record the initial burette reading. Place the conical flask on a white tile. Add the acid from the burette to the mixture in the conical flask, swirling the flask continuously. When the indicator changes color at the end point, record the final burette. And then we're supposed to repeat the titration to obtain concordant results. And the first question is, give the name of the most suitable piece of apparatus to measure out 25.0 centimeter cubed of potassium hydroxide. Of course, you should remember that to put exactly 25.0 centimeter cubed of potassium hydroxide into the flask, we use a pipette. Give the color of methyl orange in potassium hydroxide and in dilute hydrochloric acid. You have to know the colors of methyl orange. You should know that potassium hydroxide, that's the base. So methyl orange is yellow in base, and in acid it is red. State why the student places the conical flask on a white tile. We said when we're doing titration, we should have the flask on a white tile. Of course, this is to see the color change clearly. State why the student swirls the flask continuously. Of course, we swirl the flask to mix the contents, and that helps to speed up the reaction. State what is meant by the term concordant results. We said we repeat titrations until we have concordant results. And you should know that concordant results means results that are within 0.2 centimeter cubed of each other. So the difference between the results of any two titrations should not be more than 0.2 centimeter cubed. The student finds that 15 centimeter cubed of sulfuric acid of concentration 0.18 neutralizes 25 centimeter cubed of potassium hydroxide solution. And this is the equation for the reaction. Calculate the concentration of potassium hydroxide solution. So we're given information about sulfuric acid. We use that to get the number of moles. Number of moles would be concentration times volume. And remember, if we're given the volume in centimeter cubed, which is usually the case, I have to divide by 1,000 to change it to decimeter cubed. So this is the number of moles of sulfuric acid. Then we look at the equation. What is the relationship between the number of moles of sulfuric acid and the number of moles of potassium hydroxide? you'll find the equation says number of moles of potassium hydroxide is twice that of sulfuric acid. So multiply by 2, that's the number of moles of potassium hydroxide. Then what are we required to get? Concentration of potassium hydroxide. Concentration is number of moles over volume. Divide by the volume of potassium hydroxide, which is 25 centimeter cubed, divided by 1000. So the volume is 0.025, and we use that in the equation to get the concentration of potassium hydroxide. This is the ionic equation for the reaction between an acid and an alkali. Of course, the acid is something that has H plus ions. You should remember that acids are defined as proton donor. That is because when we dissolve it in water, it forms H plus ions. A base is a proton acceptor. When we dissolve it in water, it forms hydroxide ions. Now, why are the hydroxide ions referred to as proton acceptor? This is because the H plus ions from the acid, you know that hydrogen atom is something that has one proton in the nucleus and one electron in the first energy level. But if we say H plus, that means the hydrogen has lost the electron in the first energy level, so it is something that has only a proton in the nucleus, so it is referred to as a proton. So when we say hydroxide ion is a proton acceptor, this is because the hydroxide ion reacts with H plus ions, which is something that has nothing else but a proton in the nucleus. When copper 2 sulfate is electrolyzed, copper forms at the negative. A student uses this apparatus to investigate the electrolysis of copper 2 sulfate. First, describe how the student could test a sample of copper 2 sulfate to show that it contains copper 2 ions. So what is the test for copper 2 ions? We should know. Add aqueous sodium hydroxide. It gives blue precipitate insoluble in excess. That is the test to show that we have copper ions. Describe how copper metal forms at the negative electrode. First of all, you should know copper ions are the ones that change to form copper metal. Now, copper ions are positive or negative? They're positive, of course. Copper has 2 positive charges on it, so it goes to the negative. It is attracted to the negative electrode, and when a positive ion goes to the negative electrode, it gains electrons. So the copper 2 plus goes to the negative electrode, it gains 2 electrons to form copper atoms. State the appearance of copper that forms at the negative electrode. Of course, what forms is copper metal, and you should know the appearance of copper metal. What is the appearance of copper metal? It's a red-brown solid. Oxygen forms at the positive electrode. Give a test for oxygen. What is the test for oxygen? Insert a glowing splint, it relights. Insert a glowing splint, it relights. Complete the half equation for the formation of oxygen at the positive electrode. This may be an equation that is different from what we usually teach, but it already tells you that this water is going to change to oxygen. So one of your products is going to be oxygen. Of course, if I start with something that has hydrogen in it, then we will have H plus ions, and this is happening at the positive electrode. This is where we lose electrons, and then you balance. You have 2 oxygens and before the arrow and 2 oxygens after the arrow. That is balanced. Now we have 4 hydrogens before the arrow, so we must have 4 H plus, and that means we need to balance that with 4 negative electrons so that there is a net charge of 0 before and after the atom. State why formation of oxygen at the positive electrode is an oxidation reaction. Why is that reaction up there oxidation? You can't say gain of oxygen. We're not having gain of oxygen here. This is because it involves loss of electrons. Remember, oxidation is either gain of oxygen or loss of electrons or increase in oxidation number. But what we have here is loss of electrons. Question 6 says ethanoic acid reacts with methanol to form an ester, and the equation is given. Give the name of a catalyst that is used to increase the rate of the reaction to form an ester. Remember, to form an ester, we have carboxylic acid plus alcohol in presence of what? The catalyst is sulfuric acid. Remember, the catalyst used for formation of ester, or what we call esterification, is sulfuric acid. State how you would know that an ester has formed. Do you know the characteristic property of an ester? You should realize that esters have a fruity smell, a nice smell. Give the name of this ester. How do we name an ester? So if I have this was the ester, how do we name it? Remember, we start with the name of the alcohol part. Which part is the alcohol? The part on the right has 1 carbon. So this was made from methanol. So this is called methyl something. Now, the other part on the left that has the C double bond O, this is the part that was acid. So which acid did we use? We used an acid that has 2 carbons. That means ethanoic acid. That means methyl ethanoate. Again, naming the ester. You start with the name of the alcohol part, which is the part that is O something. So this is 1 carbon, methyl. And the acid is the one on the left that has the C double bond O part. So this is an acid that had 2 carbons. So that was ethanoic. And the name of the ester is methyl ethanoate. The table shows the number of bonds in the reactants and the number of bonds in the products. State which 2 bonds need to be broken in the reactants. This was the equation. Which bonds do I need to break in order to form the product? You should realize, can you see the bonds? The bond between the C and the O in the acid and O and H in the alcohol. This is what we're breaking up, and then we're going to join them together. So explain why the enthalpy change in this reaction is approximately 0. Why would the delta H for this reaction be 0? Can you see that the bonds that we need to break are the same as the bonds that we're forming? We're breaking a CO and an OH. We're also forming a CO and OH. So the same type of bonds are broken and formed. So the energy needed to break the bonds in the reactants is equal to the energy released when bonds are formed in the products. Question 7 says methane reacts with steam to form carbon monoxide and hydrogen. And this is the equation. State why carbon monoxide is poisonous. Remember, we said the adverse effect or the bad effect of carbon monoxide on health is that it is poisonous or toxic. Why is it poisonous? You should remember, because it attaches to the hemoglobin in the red blood cells. And when it attaches to the hemoglobin in the red blood cells, then less oxygen can be carried by the red blood cells. So we say it reduces the capacity of blood to transport oxygen to body cells. Explain the effect, if any, on the yield of hydrogen at equilibrium when a nickel catalyst is used. if we have a reversible reaction and we use a catalyst, does that give more product or less product? What is the effect on the yield of the product? No effect. Remember, a catalyst will speed up both the forward and backward reactions to equal extents, or it will speed them up equally. So it does not give more of the product or less of the product, it just makes the forward and the backward reactions faster. The reaction conditions for this reaction are a temperature of 700 degrees Celsius and pressure of 5 atmospheres. Now, the temperature of the reaction is reduced, so we're going to use lower temperature. What is the effect on the yield of hydrogen? Lower temperature, you should remember, lower temperature means the equilibrium will shift to the side that is exothermic. And here, the forward is endo, since delta H is positive, then that means that the backward is exo. And you should remember, if we lower the temperature, the equilibrium shifts to the side that is exothermic. So here it will shift to the left since the forward is endothermic, and that means less yield of hydrogen. The hydrogen will react with the CO to give methane plus water. So we're having less yield of hydrogen. The pressure of the reaction is reduced to 480 m. So we're going to use lower pressure. Now, when we lower the pressure, the reaction will go to which side? You should remember, lowering the pressure goes to the side with more number of moles. In this case, more number of moles is the one on the right, or going forward, and that means going forward will happen more, so we will get higher yield of hydrogen. So we say lowering the pressure causes the equilibrium to shift to the side that has more moles. In this case, it is to the right or forward, so we have higher yield of hydrogen. And the last question says, calculate the volume in decimeter cubed of methane gas at room temperature needed to produce 6.6 tons of hydrogen gas. So, we're going to make 6.6 tons of hydrogen. How much methane did we start with? Of course, we said if we're given information about hydrogen gas, for example, the first thing we need to do is get number of moles. Number of moles is mass over molecular mass. Remember that the mass here has to be in grams. I cannot put it in tons. And we are told that 1 ton is 10 to the power 6 grams. And that means 6.6 tons would be 6.6 times 10 to the 6 grams over the molecular mass of hydrogen. You should realize that molecular mass of H2 is 2. And that gives the number of moles of hydrogen. Now, what are we asked about? We're asked about methane. So we look at the equation and we relate the number of moles of hydrogen to the number of moles of methane. And you can see that 1 mole of methane gives 3 moles of hydrogen, and that means the number of moles of methane should be the number of moles of hydrogen divided by 3. So that gives number of moles of methane. Now, what are we asked to get? Volume of a gas. Volume of a gas. How do we get volume of a gas? Number of moles times 24, and that gives the volume of methane in decimeter cubed. Notice that we're required to give it in standard form, so I have to write it 2.6 times 10 to the power 7. And that's the end of this paper. I hope this was useful to you. I hope you were able to get most of these questions. Please keep revising, keep studying, and please share the video, and good luck on your exams. Thank you for listening.